Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Unraveling Machine and Social Data Analytics on the IBM Big Data Platform. Our guest speaker today is Mr. Srinivas Kulkarni, Senior Architect, IBM Big Data Platform and Solutions at IBM India Software Labs. Kulkarni has been working with IBM for over 12 years with various roles and experiences in product architecture and development, solutioning, enterprise integration, customer enablement, and technical evangelism. In the recent past, he has worked extensively on many Smarter Planet initiatives like Smarter Supply Chain, Smarter Food, Smarter Healthcare, and the Internet of Things. He is a prolific inventor with multiple patents and publications in his portfolio. One of his focus areas for this year is to enable Indian academia and the technical community to get started with the big data analytics. So without further delay, I introduce you all to a guest speaker. Over to you, Mr. Kulkarni.
Thank you. Thank you, Moini. Okay. Yeah, I hope you are able to see the screen with the title. So,
yes, we can.
What we'll talk about today is basically I wanted to talk more on. We had a similar webinar 6 months back where I talked about what big data is and big data platform should have capabilities and so on. And today I wanted to specifically focus on two types of analytics that we are seeing a lot of traction around in the big data world. Right? So one is the machine data analytics, the other one is the social data analytics session. I will be covering a bit about what we mean when we say big data, what are the challenges available there, and the opportunities that make it. And what type of platform capabilities that are needed. And then I will get to specifics about what are the challenges and solutions available in the machine data and social data analytics. Okay. Yeah. So I'm on a slide named Data is the New Oil. Right? This may sound a little intriguing, but the reality is in today's world, right, data is becoming so important. It's treated equal, or if not more, to the oil. Just like oil or any other natural resources, data is yet another natural resource. There is immense potential in realizing some business value of the data, but hardly many people are actually using it. Right? If at all they're using it, they're using it for maybe one particular purpose. Now, one of the reasons is just like natural resources, data comes in a variety of forms and in abundance, extreme abundance, and it is very, very undefined. So in order to make any insight out of that, one has to do a lot of analysis, give it some structure that one can understand, and the structure and the analysis varies from use case to use case. Right? But needless to say that this is where we are seeing a lot of organizations putting their effort. They're starting to figure out how we can leverage about the data. The data could be the internal data, could be in the form of the call center data they're getting, the emails they're getting, the various blogs they have, various intranet data, or the CRM databases, or the structured things like CRM databases, or the master data, and so on, and the sales, transaction, all this data, right? And the data that is external, maybe social media, maybe data that is getting generated in the news media, and so on, right? To figure out what I can make out of that. Now, one question that I generally get asked is, really, how do you define what is big data, or rather, how big is big, right? And there has been a notion that big data is Hadoop. For those of you who know what Hadoop is, the answer is yes and no. Yes, Hadoop is part of the big data that we're talking about, but that is not the only thing. So generally, there are a few characteristics that we are seeing when it comes to any big data use case. One is the volume part of it. There is immense amount of data that I want to analyze, and my traditional systems are not the right approach to go about them. Right? So we're talking about from terabyte to hundreds of terabytes to petabytes to just we are expecting in the zettabyte range very soon. And then, as I mentioned earlier, there is a variety of data format. The data coming from various machines like RFID sensors, your own application logs, network routers, and then various devices and so on, and in different formats. Right? So we need, how do we handle all these things and make any sense? And because there are so many devices and so many sources, the data that is hitting us is at an enormous pace. We are seeing at some cases things like 5 million data points per second, and yet people are looking for, can I get as real time as possible to act on it? So velocity is not just the way the data is coming at you, it's also how quickly can I action on the data that is coming in. Right? So, and the velocity and volume are kind of linked, because the more the data hits you at a high rate, and the more you want to store, the volume grows. So, for a couple of years, we've been talking about the velocity, volume, variety, and all those, they're known as the 3 V's. And there has been a notion that because there is so much of volume, statistically, it will even out even if the data quality is not so good. But that is not really the case. Right? In fact, because the data is coming from so many sources, so many variety of forms, how do you really trust? And figure out how much of the data is relevant for the analysis that I'm doing right now for this particular use case. Right? So that's when the veracity part of the other dimension of the data characteristic is really there is a lot of uncertainty out there. How do I predict what is inherently imprecise data and figure out the reliability of it? Okay? So these are some of the characters. Now, of course, there are multiple these people are talking about. Like, more data you add, the more analysis you do, the more insights you get, and then it attracts even more data. Someone call it veracity. And I'm seeing something like 15 V's in the same space. But suffice to say, these are at least the 4 things that we are seeing almost must. So just to give you the sense of the numbers that I was talking earlier. So in the 2010 to 2020, in 10 years, we are thinking, we are seeing almost 50 times growth in volume. We're talking about close to 30 zettabytes of information. And we already have billions and billions of devices. And one of the key things about this is a lot of this data, around 80%, or in sometimes experts vary between 80 and 90%, is really not structured data. Now, we've been used to dealing with structured data for ages, and we have figured out various ways of how do we deal with it, what we can achieve with it. But a lot of this we are seeing is unstructured. When I mean unstructured, it could be in the form of text, or it could be in the form of images, videos, or feeds coming in from various medical devices, or cell phones, RFID devices, all kinds of things. It doesn't absolutely have any structure. You need to bring some structure to it, and then go for that with it. Right? And just to give a glimpse of what veracity is, when one of the surveys we did, we figured out that 1 in 3 business leaders don't really trust the information they're having to make decisions. Right? So that is just to give you an idea of how important the veracity part is. I just want to next give you a sense of kind of applications or the use cases that the big data technologies are trying to solve. And all of these are real use cases, by the way. Not taking the names of the customers, but they're all very real. So in one case, there was this government organization. They wanted to figure out intrusion detection, and they had laid out these acoustic cables, a lot of fiber optic cables, which would generate acoustics data. And it was like 5,000 individual streams, and in terabytes per second, data was coming in, and they had to analyze all that and figure out where actually an intrusion has occurred. Right? And you cannot expect hours of analysis and then figure out, oh, that is where it might happen. So we have used some of the real-time analytics capabilities to bring it from hours to just 70 milliseconds. And there was this utility company which had a lot of these smart meter installed, and what they were up to is, can I bring down the load on the grid? Can I predict how much the load is going to be? And one of the things that they wanted to figure out, I want to charge higher for peak hour usage, and so that way you ask people to use less, incentivize off-peak hour things. So again, this had a lot of these millions and millions of smart meters talking to each other, and then saying, this is my actual consumption that's happening now, and based on that we could actually predict in real time where the consumption is going to be, where do I need to route it, and how do I optimize the whole thing. Right? And another interesting use case is, which is my favorite, is in hospital. So this is a neonatal care hospital in the North American region. They had these prematurely born babies, which are kept in incubators, and these incubators have some 30, 40, 50 types of devices attached to them. Typically what happens is a doctor or a nurse comes every 15 minutes or an hour, just looks at the various graphs and data points these devices are generating, and then seeing, okay, things are fine, they're not fine. But one thing the researchers realized was that if we can correlate all these data in real time, right? The data coming from, say, ECG with the EKG, with the heartbeat monitor, with humidity, temperature, all those things, we could actually predict an onset of an infection much ahead of time. So in this case, the researchers could actually figure out that an infection might occur 24 hours in advance. Right. Now, for a 2-day-old, a 3-day-old baby, this 24 hours is a question of life and death. And that's just because we can do this massive correlation across multiple types of data in real time. Now, I can go around. I know in the interest of time, I just skip the other things and just move on to thinking about. We talked about the real-time analytics. We talked about we want to do the whole volume type of analytics where I look at, so I just missed in the previous slide, there was this a retailer, they wanted to analyze years and years of data to get what is the buying pattern, what's the behavior, and so on. So that is the other aspect of it, which is I'm doing a lot of historical analysis. So there are what we're seeing is there is most of the use cases, there is no one way or the other. It's a combination of many of these things. Right? So to look at one is you need to figure out how do I ingest this enormous amount of data? Right? How do I handle all these things? How do I extract structure out of the unstructured data? And then the next thing comes is how do I do deep analysis? So in the sometimes when I earlier said I asked this question, how big is big? One is the volume that determines it's a big data problem, and sometimes it may not be just the volume, but it will be about how deep the analytics that you're interested in doing. that qualifies as a big data. And related to that is what you're saying here. If you want to analyze some anomalies, certain patterns, because ultimately it's all about figuring out, is there a pattern, is there an anomaly there? And I want to augment it with my existing traditional warehouses and other things. Of course, now there is so much of data. Where do I actually begin with? And I need some kind of experimental ad hoc analysis, something that will help me visualize or navigate further. So these are some of the themes that we generally keep seeing when it comes to big data applications. And I'm talking from my personal experience of building few of these. Because the challenges of, say, real-time analytics is quite different from a challenge of offline or historical analysis, there is no one technology that will work for all. Right? So you have to target specific technologies for specific things. For example, we use Hadoop for offline or historical analysis of a huge amount of data. So we have this one financial institution which was interested in figuring out microsegmenting. And when we're talking about microsegmentation today, most of the segmentation happens on demographics, like all the people having in this particular age range, having this range of earnings, living in a metro, have this kind of spending habit. And based on that, they'll have their fraud detection modules or upsell, cross-sell modules, and so on. But it may so happen that I, a person who, even though I fall in that group, in a particular month, because it's my birthday or it's my anniversary, I spend a lot of money. Or every year, if you look at December, I go on vacation or I spend a lot of money. So anything huge variation from my regular thing is not an anomalous thing for me at that point in time. So if you really want to personalize your offers or personalize your service, then this company wanted to build models on an individualized base. Right? They wanted to do this microsegmentation where n is equal to 1 at each individual person. So they took the 7 years of the credit card history of each credit card, all the credit card transactions of each person, and then built individualized models. Right? So these kind of things is where we find Hadoop is the right choice. When it comes to the stream, the real time, the data baby talked about, the neuronuclear, that's where we use a technology called stream computing technology. And again, this is well-known technology, and there are a few vendors who offer this. Then there is things like I want to do a lot of unstructured analysis. I want to do text analytics. For example, any social media analysis, I want to understand what the mood of people is, what the sentiment they're talking about, what are they interested in buying, and so on. Then I have to do a lot of text analytics. Now, you wouldn't start with very basic things. How do I identify a verb? How do I identify a noun? And then start writing the Java parser or the C parser or the Perl. Or if you start doing at that level, that's just too much of a task for a developer to do. So you need higher level constructs which can help you do these things. And on top of it, we can build quicker applications. Another thing is most of these use cases will have, big data will not be sitting in a silo. They will have to have integration with the rest of the information architecture. You have to see if you're doing a social media analysis is how much, whether people are liking the product that I'm selling, and if you figure out in the Bangalore region people are liking it, but if my sales data is not supporting it, then there is something wrong. So in order to do that, I need to merge or marry the two worlds, the structured world of my sales and transaction data with the unstructured world of social media or call center or other data. So seeing that all these things as I mentioned earlier, there are multiple dimensions, and you need multiple type of technologies to handle these things. So when it comes to analysis of raw data, we think it's the Hadoop world, and we have a product called InfoSphere Big Insights for that. And when it comes to simplification of your warehouse, and I want real deep analytics on pure structured data, there is IBM Netezza, which is an appliance, and then you have streaming data with a product called InfoSphere Streams, and for when you actually start new things, right? When you don't know anything, where do you start? That's when you have to throw data to some application which will give you some sense of where the insights will come, so that you can spend more time analyzing that. And for that kind of exploratory analytics, there is a product called InfoSphere Data Explorer, which came through an acquisition we did this year. So together we call it big data platform. And whatever I'm saying here, this will apply to any future vendor who will come up with. These will become kind of the key things. You cannot just give one thing and say, I am working on a big data platform. All these are so much complementary that they become a necessity. Now, one of the key, interesting thing that came up when we did a survey with most of, some of the customers who were embarking on a big data journey, it was around 2 years back. We said, what are your challenges? Where do you think you have issues, and so on. We were expecting the standard volume problem, the velocity problem, and the structured, unstructured nature, and so on. But what was very interesting that came out was most of them said, I know there is a lot of data in here. I know there is a lot of value in analyzing the data, but I don't know where to start with. Right? And because it is so, it's like unknown. Right? And then that also led to the thing that you start somewhere, do a bit of experimentation, and explore and keep iterating it. So that's why we call big data analytics all about exploratory analytics and iterative analytics in an iterative manner. So unlike the traditional analytics where business guys came to you and told, I want a report, this particular requirement, just give it to me. IT built it and got the report. That's not the case with big data anymore, because business themselves don't know what to do, where to begin. So they're saying, give me a platform where I can explore myself, because I have more contextual information than you have. So that's where, connecting to the circle slide I had, this slide makes sense. Is we have a big data platform which has the whole thing about information integration, information governance layer, and on top of that, different engines. So offline analytics engine for Hadoop, for real-time analytics from stream computing, and the warehousing engine, and the contextual search engine is where you start exploratory work. Right? That's our platform capabilities from and then what we realized when we were working with many of the customers was building a big data solution is not an easy thing. A lot of things, even though we have given us out-of-the-box toolkits and so on, they still had to build a lot of things. So then what we did was, let us take all the industry knowledge that we got, and based on either per industry or for specific use cases, we will build reusable frameworks or assets, which we call the accelerators. Right? So we give these accelerators with the platform itself, so people can quickly build their solutions on top of the platform using or customizing the accelerators that are available. And of course, big data, any big data platform has to have a visualization, because big data has its own visualization challenges, and you need, you cannot go and start with a Java or a C++ IDE. you would need a specific IDE for big data applications, right? And of course, monitoring and managing the whole cluster of information around big data. Right? That's another thing that you need in the big data. So all these things put together is what we call IBM Big Data Platform. Though they are individually, they are sold as independent components. It's not one from a sales play, but it is more from how integrated they work with each other. Okay, so that was a brief, or rather a little more than a brief about the big data platform. Now I want to get into some of the reusable components that were built, which will help you develop your applications faster, which we bundle with a big data platform. So there are 2 or 3 types I can call it. So one is which are very specific to applications or domains, and the other ones are a much lower level. You may or may not be qualified to be called accelerator, but for the lack of a better word, I just call it. One is, say, text analytics. And so I mentioned already that dealing with raw text. For example, if you look at the example here, right? It is some snippet from one of the sports news site. It says there is a football World Cup and a team distinguished themselves losing to eventual champions and so on. So there is references of countries, there are references of things like striker, which is a role. It's like, in Indian context, you can think of like a batsman or a wicketkeeper and so on. And then there are references to people, and then there are references to the game itself. Right? And so how do I really figure out what is what? If I have to give it to a machine, I have to give it some structure. Right? So if you look at the classification below, all the names have to be in one column, all positions or the people have to be in another, and based on the country, and you can just keep on adding whatever you want. For example, you take maybe financial statements. There will be so many things. There will be talks about competition. There will be talk about the products people are, a company is manufacturing. There will be talk about the profits and losses. There will be talks about acquisitions, mergers, and various divisions, how they are working, right? And of course, the money is being spoken about. So, if I want to do any analysis on top of it, I want to automate all those things, I have to have capabilities to extract these things. Right? Now, I'm stressing more on the text analytics because most of the stuff I'm going to talk next heavily relies on the text analytics. Okay? So, how have we been doing text analytics in the past? Traditionally, is people have built various things on regular expressions. With you write a lot of rules and to identify various things with regular expressions and dictionaries, and so you apply a rule and it applies the regular expression, goes, finds it, and sometimes it says, oh, this is not matching. Now let me see the rule 2 fires and rule 3 fires and so on. Now this is a highly CPU intensive operation. And because we are doing this backtracking and going back and forth, it's extremely time consuming, right? So, and you have to build everything from scratch. So where we came up with was a radically different approach to text analytics. And this was based on how we are dealing with databases, how we have relational algebra, which simplified the whole database technology and helped us build a whole set of optimizers, so that as a developer, I need not worry about writing the optimal code. I write it at a higher level declarative way, and the system does all the optimization that is needed. Right? That was possible because there was a whole notion of relational algebra. It was based on that mathematical model. So we applied the same relational algebra to text analytics, and the result is we have a system which is 20 to 40 times faster than the best text analytics applications that were available at the time we built it. And even today, this is the fastest text analytics. And more than anything, from a scaling point of view, those who know SQL can just pick this up because it is based on the same relational algebra and same kind of constructs. Right? Things like select, clause, projection clause, where clause, predicates, the same sort of things are applicable. So that way we can, people can pick up these things quickly. And we provide all the basic constructs like parts of speech tagging, things like sentiment, all those things come out of the box. So one need not sit and do all those things. And of course, extracting all these things. And there's a language that comes with it. Similar to SQL, we call it EQL. Now, based on, this is one of the foundational things for us, right, the text analytics. Now, so I was talking about the financial reporting and other things. Right? So we have some things in the space of financial analytics. One is based on the stream computing. It is how fast can I analyze the stock trades to figure out whether something is going up or down. And we have some toolkits called time series toolkits, which will look at the excuse me, look at the pattern of things like in the sine form or whatever waveform that it is coming in, and then I want to analyze and see if there is a pattern here, if there is an anomaly here. So a lot of those things have gone into the financial analytics. And then we have specific accelerators meant for the telcos. We have handled some of the biggest telco volumes. For example, just in India, we have some telcos who are having call detail records, or the CPRs, in the range of 6 billion per day. And they're having big challenges in terms of how they can analyze them and figure out how many priority customers calls are dropping, how many by maybe things like calls to which country are not really going through, getting cut or whatever. And I want to do it in real time when billion people are talking simultaneously. So that's those assets we have put it as part of the product now, and anybody who's interested in taking it further and customizing it can take that. And of course, there are the topic of today, which is social data analytics and machine data analytics. I will talk more about that in the upcoming slides. So getting into social data analytics. The machine data analytics. If you take any of the things, the smarter cities projects, where I want to talk about can I streamline traffic? Can I figure out things are moving smooth or whatever? There are so many machines which are generating data. And when I say machines, it could be devices, or it could be very high-end machines like a mainframes. It will range from all kinds of machines. Right? They're generating, and as you know, these machines generate data in all kinds of log formats. Within them, applications have different logs in themselves, and they are generating a lot of data. Similarly, when it comes to the healthcare, I talked about the data baby use case. Again, that's machine data, right, in different forms. We're talking about I want to look at what's the criminal history of some suspect, what they are doing, are they calling each other, is there any pattern there, how do I actually track those suspects, and so on. All that comes under the law enforcement investigating agencies. Again, huge amount of machine data getting generated. All this real-time machine data. So what we are talking about is handling this machine data. Now, let's look at some of the challenges that handling machine data brings with it. One is the data sources are diverse, and the formats are quite complex. And sometimes they're following some standards, and most of the time they're not standard. So either they're vendor specific or they're application specific within a vendor-based application. And the data, the volume is extremely large. I have seen cases where some customers have had almost close to, in one data center itself, close to 2 terabyte logs generated every day. like every day. And the kind of analysis, now if you want to do any analysis, you have to have, say for example, I want to detect is there any correlation of multi events across the logs? Has there been a pattern there? Is it going beyond the pattern? If I want to do any of those things, I may want to store a year or 2 years of data, right? And then maybe I want to build index. I'll just get to why we need an index. Then we're really talking about large-scale indexing of these things. And then next thing is, how do I really visualize all this data? How do I get any sense of it, out of it? And if things are happening, can I get anything in the real time? So on. Right? But more than anything, key is in the machine data analytics is the formats are varied. And another thing is, suppose there is a, just let's consider more on the logs, machine logs itself, right, than any other set of data. If there is a failure, and I want to figure out a root cause, why something failed. Now, if there is a failure in the application, right? So think of that an application is built on a, on a middleware, and it uses a database, and is sitting on an operating system that uses a network, and so on. Now, in any of the layers, right, there is a middleware, database, operating system, or network, or physical, anywhere things might have gone wrong. So if I just look at application logs, I may not be able to get anything out of it. So I need to somehow figure out what was the common thread across all these different layers. In other words, can I build a session across all these things so that a particular transaction hit all these layers, and whenever the transaction failed, there was this particular pattern. And then I can look at previously whenever this happened, has it been the same case? Now this is possible only when I integrate analysis across all the layers. Just as one example, now this is when I'm talking about one machine in all the layers, but typically it will be clusters of machines in the real world. So I need to figure out how do I manage all that. And these are some of the challenges that we are facing. So in the next slide, I'm showing you where we're heading actually when it comes to, some are available, some are still we're working on. Inside, look at just the inside part of it. The left side shows the various log formats and sources, and the insights we're talking about is what are the root causes, what can I find out pattern detection, anomaly detection, and can I predict failures? One is something happened, I give the root cause. And now second thing is I want to do something preventive. Can I really predict a failure before the failure happens? And the other one is, can I do any resource management? Again, it kind of comes to the prediction part of it, that these set of machines are going to go down. Or this particular fan, the way it is behaving, I know in exactly 3 days it's going to go down, so I need to replace it. Right? So that kind of the resource planning that I can do with it. So now let's look at the steps involved in order for us to arrive at these insights. Right? What do we need to do? First thing is, we need to figure out how do I ingest the machine data into the system, whether it's a real-time or a Hadoop kind of a system. Then is how do I give a structure to it? Right? In order to do a structure, I need to extract. If you look at any log or any machine data, there will be some things. There will be a date, typically a timestamp, and if there is an error message or something, what is the error message, and which component that came from, which machine this happened, it could be IP, and some other such information. Right? So think of them, each of them, as individual entities. So there has been a traditional way of doing it, where you write parsers for each type of machine log. Now, because there are so many, thousands and thousands of types of machines, it almost becomes impossible for any one application or any one framework to give you all those things. So the parsers become, writing a parser becomes a headache. Right? over and over. So the approach we follow here is we look at these common entities and give common extractors. So for example, date can occur in some 15 to 20 different formats. So we have written all those extractors using our text analytics capability. Again, as earlier mentioned, the text analytics capability is one because it's easier to write, and the second thing is extremely fast to pick up what they're interested in. Then I want to do faceted search, and then I want to do a large-scale indexing where it comes as I want to search for some particular event happening, and what happened around that event. So it becomes very important for me to build a search index. And this is not like a database index. This is the Google type of text search index. And then I want to do certain transformations so that I can make it available for some statistical modeling and apply certain machine learning techniques. Now, where we apply statistical modeling and machine learning techniques is to do any predictive analytics, to build a model out of this large amount of data that you have got. Rather than talking, let me just start showing you some of the things. So when it comes to, say, data indexing, so I talked about facet. Let me tell what real facet means. So if you've ever been to some website like eBay or Amazon, you will see on the left-hand side, right, on the navigation bar, things like some classifications, like this is an electronic item, and then there is another facet which says it is between 200 to 5,000 rupees, and then there will be other thing which says the seller is from this region. So those are what we call the facets. The data has different faces, the way you will look at it. The same case in the case of logs, you have date is one facet, and the error message is one facet. Component could be another facet. And any entity we extract out of it have different facets. So what will be interesting is for me when I'm doing a search, I want to configure what facets I'm looking at from a data scientist point of view, and then can I correlate across different entries in this one. Right? So one simple thing you would chart is based on a date range search. So there's a time graph you can see just on the top, right? And just I can look at time distribution of how the events are happening, and then if there is just visually I can figure out there is a spike somewhere. And by the way, this automatically takes up depending on the number of hits it gets, whether it should be in hours, minutes, or milliseconds, or days. It will figure out. It will give you the that time distribution, right? And one is you can click on something that was depressed, either something went really low or something was very high, and then it starts showing you actually what happened in that. And on the left-hand side, you can click on things like I'm interested in this particular specific IP, or it could be on a particular date, and your search gets restricted only to that, and so on. So you can keep exploring it. This is very, very simplistic, most basic thing, right? And then you start doing further analysis, and you can do wildcard searches and so on. Then that is more for someone who is doing the root cause analysis of data scientists and so on. But what is more interesting is if I am doing any, if I'm interested in pattern analysis. So that's when we do the statistical modeling. So to figure out what has been a frequent sequence or a subsequence there. For example, when certain failure happens, right, we see that we will try to apply certain pattern detection and see whenever this failure A happened, this was preceded all 20 times. This was preceded by X, Y, Z, W, those set of events all the time. Now, that gives me that if 20% or 80% of the time same things are happening, that means it's very likely that whenever this X, Y, Z, W happen, the event A will happen. Right? So that's based on that, I can start predicting. And I can figure out what are the top key devices maybe per device, per machine, per IP, any of the facets you can choose, and then do the top key analysis on top of it. Like what are the top patterns? And I can do similarly for any correlation analysis. Can I link event that happened in an application server with something that happened in the database, and then see how they are related to each other? Is there any similar thing happening? So one is you can look at faceted search, find an error at the time frame which is reported, and you can drill down further into time range, get interest, and note the code of category, and further do it for root cause analysis. And this is what I was telling you, it's just shown here in the picture. And then we have this spreadsheet-like analysis. There is a tool called Big Sheets, which will help you, think of it. Most of the data scientists are used to Excel kind of things for most of the analysis. But Excel works only on a limited data set. The moment it gets into a large data, Excel is not the tool for you. So what we have put together is Excel-like spreadsheet kind of capabilities. It is run on a browser, and you can do all the analysis that you can do in Excel, just that this can be run on a MapReduce manner, which is what is foundational to Hadoop, and it can run on any amount of data. It could be terabytes or petabytes of data. So similarly here, what we are doing here is we are seeing how we are doing a join across different types of logs, like for identifying the key performance indicators to create sessions. So in the next one you'll see, which gives me some kind of KPI as which KPIs were the ones which are causing, were most influential in causing errors. So I can see it in pictorial form. And all these things actually comes out of the box. And you can still customize it further if you want. And then if I want to look at some other bigger picture, and I want to look at patterns of frequently errors, how frequently they're happening. So this, if you can read, I don't know if you can read, it's very small font. The blue bar basically says a specific stayed down, session has gone down, and it has happened 220 times in the data set it had, and so on, right? So some of these you can create as a canned reports, or use what is available. So to sum it up, where the machine data accelerator helps is, one, a lot of these parsing is built into it. So you throw most of the data formats, and you're going to get all those things are built in. You don't have to sit and build all of these things. Even if there is a new data format your log is creating, it will most probably have the common attributes. It just may be that the positioning may be different. For example, we will be supporting maybe extracting our date will come a little later, and before the error, and so on. So even if that is the case, this machine will pick it. So the kind of things you can do is, as I mentioned, frequent sequence analysis, various KPI correlation with events, can I do root cause analysis, and so on. And this is one accelerator that has been extensively used in many of our customers, and has gotten us a lot of interesting insights. In one case, one customer just wanted to test how this worked, so just introduced some uninteresting stuff in the logs just to see whether it picks up. And the system just went exactly that place and picked up. This is something anomaly. This is not expected here, it's coming here. Okay, I'll just next move to social media analytics. needless to say, why we need to do social media analytics. Everybody's talking, and people are looking at how do I reach to a different set of customers, what kind of products they'll be interested in, what they want to buy, is there a risk in my reputation, brand reputation analysis, and can I figure out customer churn, can I retain them, can I acquire new customers, so on, various analysis that we can do. So typically when we talk about social media analytics, right, people only talk about sentiments. Can it give me sentiments, positive sentiment, negative sentiments, influence, and so on. But the way we see it is that's past. What we're looking for is the next thing is when we see people talking in the social media, we have no idea who they are, other than what they have written already in the profile information, which most of the cases is not really the accurate data. But one can find a lot by analyzing what they are talking about. Right? I'll take some examples in the next slide, which says someone is talking about life events. He says, I'm off to Stanford, right, for my MBA. Now you got some information that this person is getting into a management type thing. And someone says, I'm moving, or I just graduated and thinking of buying a car. Right? So one is you're getting life events of various things. The second thing you're looking of people's intent to buy. I'm interested in buying an iPhone, or interested in a smartphone. Any suggestions? Someone is just asking in Twitter or Facebook. Now you can look at that and figure out, oh, there is an intent to buy here, and what specific things they're looking at. And they're talking about locations they visit, the locations they live in, and these locations could be as simple as I live in Bangalore, or visit Bangalore, or it could be I love Big Apple. Now, by the way, Big Apple is another word used for New York. So the system can handle all these variations and figure out that this person is actually talking about New York. Or he may be saying, I like going back to Yankees. Again, you're talking about New York, not using the word New York, right? And you're talking about various personal attributes. So someone says, happy birthday. Even though the person hasn't mentioned the birthday anywhere, the moment you know birthday wish was made on 14th December, that means the person's birthday is on 14th December. Right? You can decipher many of these things. And the preferences, the hobbies that the people are having, relationships. Someone says, happy anniversary, wife. So you know the two are linked as the relation called wife, husband, spouse, and so on. So this is the space that our social data accelerator is actually targeting. Right? One is it will build a social media profile of customers, even though you don't know anything about them. Right? And the next thing comes is, how can I resolve them? Now, there is a profile built based on the tweets on the Twitter sphere, and then there is something like Facebook. Right? So this aims at merging across the social media and finally coming with one global user profile. So they're saying a Twitter handle called Kulki is the same as a Facebook handle called Srinivas Kulkarni, and the same as Srinivas S. Kulkarni on LinkedIn. And I got 4 attributes from LinkedIn, 3 from Twitter, and 4 from Facebook. Together I put this, and this is the global profile of the customer, which will have all the things that I talked about. Similarly, when it comes to different entities, businesses, there will be all kinds of things. We'll be talking about competitions, investments, and various things. And sentiment and the buzz, all those are fundamental. Those are basic. We're taking them for granted. So from insight point of view, right, you can look at the intent to purchase or intent to plan. So you can, when you want to do a targeted campaign, you know whom you actually should go after and not go after everybody. And then business relationships, what people sentiment they are having, what preferences they're having, what hobbies they're having. Right? All these things actually come out of the box. And another interesting part, and the key part of the social data accelerator is it has 2 parts to it. Right? One is the real time, the other one is the offline. So whatever the profile building I talked is mostly done on offline, maybe based on 1 year of data or 2 years of data. Once you have got the profile of the people, right, then in real time, as soon as a tweet comes in, right, you know there's a handle called full key. I've got a built a profile for that. And full key says this particular service was really not good. Or he says, I'm interested in buying a home in this particular location. Now you know who is speaking, right? And based on your past, you can figure out also why the person is speaking the way he's speaking. I think so. This is all done in real time. So we worked with. I'll take a live example where we worked with one of the movie houses. So think of it, right? Whether a movie is going to be hit or not, it's one of the most unpredictable things that you ever come across. For example, movies, these are, think of India itself. Hundreds of crores people are spending on movies. They are doing a lot of launches, campaigns, all those things, and the promos. And something like IPL match is going on, and I want to launch a promo. And I want to see what people are saying about that particular movie. And not only what they are saying, whether they are happy or not happy, but what are they happy about? What are they okay about? Is it about the cast? Is it about the plot? Is it, they are saying, because there is Shah Rukh Khan, I like this movie? Or is it because, it's done by Anurag Basu, that's why I want to go after it? Whatever. And who are the people who are saying that? Right? For example, if you're targeting a particular movie, I'm talking about movie, but you can think of any business for that matter. Right? I'm targeting this campaign for an age group of 25 to 35. Now, if my social media analysis in real time can give me that people between 25 and 35 really did not like it, and because of these reasons, whereas people between 40 and 50 living in a suburb, in a non-metros, they liked it a lot. Now, you can do a lot of things. Right? One is you can take action as, I need to change the promo, because you're getting all this in real time, which otherwise was not possible earlier. So that is one thing. And the second thing I can do is, maybe I don't want to launch all these things in a metro for that age group. So change a little bit, and I want to launch it in a different set of screens or a different set of places. Or I want to add more budgetary funding to make this happen. So opportunities are huge just by making the real-time analysis of the social media and giving you answers before it's too late. Right? We're talking about, we did this analysis with 1 billion tweets and built a profile. And in real time, we are watching for what people are talking about, set of movies, and how they are comparing. And we figured out one movie they talked a lot good about, and the other movie they just did not like the promos. And the box office actually proved it the same. So yeah, I can just go on, but I just want to stop at this point and then mention that the key things in the social data accelerator are extracting these different social profile attributes and then resolving multiple social media profiles to figure out these two people are same, and maybe resolving that with your internal database data. And most importantly, this is not just uses like a point kind of a solution. You can use it out of the box, but you can customize it and build your own things. And all these things come with the product, with the platform. So I think I'm running out of my time. With that, I'll just leave it. The only thing I'll say is if you're more interested, you can look at a YouTube channel called IBM Big Data. And there is also a website called bigdatauniversity.com where every basic like Hadoop, fundamentals of stream computing, text analytics are explained on a hands-on kind of basis. So that's just if you're interested further. Yeah, so I'm done with my presentation. If there are any questions, I'm open to them.
Well, thanks for the insightful presentation, Mr. Kulkarni. Let's quickly take up the questions. I have assigned you a few questions. Can you see them in your
Okay,
questions pane?
let me, yeah. I'll just open one. Give me a second. Uh, okay, there's a lot of questions. Okay. Uh, okay, so there's one question which says, is it possible to do real-time analysis using big data? Example, Hadoop. If so, then does that mean in near future we can replace traditional relational databases with big data? Yeah, thanks, Kunal. It's a very interesting question. First thing is, yes, we can do real-time analytics, just that it is not on Hadoop, because Hadoop is not fundamentally meant for real-time. It uses a different technology called stream computing. So your second part of the question is it going to replace traditional databases? I really doubt that. Because when you're talking about the real time, it will actually in fact enable those relational databases. So one thing is there's so much research that has gone into relational databases in the last 30+ years. I doubt that people would really throw away all those things and go after this one. Whereas what will happen is the overall approach may change. For example, the telco use case I was talking about. So what they were doing was they were taking these billions of records and pushing it to a warehouse, and then they did cleansing, deduplication, and so on. Right? That was taking a lot of time. So what we brought in was we brought in this real-time analytics, which did all the cleansing and deduplication and all these things upfront before it actually hit the database. Right? So now that made a big difference. So it will be the combination that will actually eventually go, but I don't really see a replacing the database itself. Of course, on the database side, there you're seeing a lot of these in-memory based databases and so on. Even then, they are not replacing the disk-based databases. Of course, unless there is a huge shift in the hardware side itself, which we don't know, we can't predict it. But the real-time analytics is augmenting databases, not going to replace. Hard to say. Okay, I'm reading another question. Okay, it says if you can help us to understand any use cases for transactional systems, activity and position in capital market. This is from Ram Jha. Sure, Ram. So we can one of the use cases I can talk about again in the real-time analytics, because in the transactional system. So I think one I talked about the credit card microsegment, that is on the offline side. On the real-time side, we built one of the fastest options trader. Right? So this had this 5 million data points that were hitting, and these data points were coming from weather sources, from their Department of Agriculture or so, and various other things, and the things like NYSE and the other stock market and so on. So think that if there is a news that breaks out that there was a fire in one of the warehouses of some retailer, now within milliseconds of news coming out, before it reaches, the stock will either go down or whatever happens, right? So we need, if it's algorithmic trading things going on, we need to do analysis as early as possible. So in this case, we could build it, we could do this algorithmic trading within a few microseconds. That's what I've seen as one of the fastest options trader. This is more on the options, not on the stocks, though. Pricing for the option. So yeah, that is the use case on the capital market side. And of course, then we are also having some things on in the capital market side itself, analyzing if there is any anomalies in the trades to figure out if there is a possibility of fraud or so. So those are also with multiple in NASDAQ or NYC type of organizations we are working. Not exactly those, by the way, but in different countries. We're working on those. There is a next question by Ravi Kumar, which says, can you give me a glimpse of data modeling for big data? I think I kind of talked about when I talked about machine log analysis. So one is the similar things that you do. If you talk about when you say data modeling, the schema and other things, it's maybe a little different because I didn't mention about the NoSQL or the not only SQL movement we're talking about. But from building a model perspective, it still remains the way we used to do it, just that the speed and the volume are the ones that are varying. Otherwise, you can apply the same statistical modeling techniques or machine learning techniques and build a model. Yeah, the interesting part here is typically the model building happens on an offline basis using Hadoop system, and the storing of the model happens in real time in using the stream. So that's how the two can work together, and we call that adaptive analytics, adaptive real-time analytics. So that whenever the real-time scoring thing sees that the model is out of date, it can go back and tell the Hadoop system that this model is out of date, rebuild a new model with additional data that you got, and then look at it. There's an interesting YouTube video on that. If you're interested, you can look at search for IBM adaptive real-time analytics. Okay, so I'll take another 2 or 3 more questions. Let's see. Okay, there's one question about how do we integrate with legacy systems like mainframes. So with our platform, we are building a lot of these integration capabilities, and with that integration capability, one can do it. So there is no answer in either the open source or just that. These are like connectors and adapters kind of a thing. Be it different databases or different things like warehouses, Netezza, Teradata, or governing systems like Guardian, we have those integrations built in. Okay, so then the interesting question is how do you go about sizing the projects with IBM Big Data Platform? This is a very subjective question. Unless I really understand the use case and the type of the sources available and the analytics that we are interested in doing, there is no generic answer. Unless I get to know those things, it's very hard to really see whether it's resource sizing or hardware sizing. So it's pretty much dependent on these different things. And the next question is how effective is unstructured analysis? We have seen good analysis. So I have worked on some things where we did a call center analysis or email analysis and got some very interesting insights which otherwise would never have gotten if we had not done the unstructured analysis. And the same goes with image analytics and video analytics and so on. So we have good systems and have very interesting use cases. And of course, the movie, the Twitter analytics I talked about, I think that should also explain how effective it can be. Okay, then there is another question. What is sentiment data analysis, or what do you mean by sentiment analysis? Oh, okay. So this is about when people talk about are they happy about some product or not happy about it, or what is that they are okay with. So it's all about the mood, how my mood was, right? Talking about it. So That's what we call the sentiment analysis. How is it cost effective? What is the cost of real-time monitoring? So that's a very good question. Prasanna, thanks for that. So cost effective is one coming from, typically when I want to do any of these things, either you build zero time, very, very expensive hardware, zero downtime type of hardware. But that has been how traditionally it has been doing, right? What these technologies, we're talking about Hadoop or streaming, we are saying using the commodity boxes where machine failures are given, and I want to build a software tolerance and software fault tolerance, and then just by adding more and more commodity boxes, can I scale out? Can I get the performance that I want? Right? So those things actually make it cost effective. And in cases we've seen, at least I've seen in one case, just in India itself, they were doing some specific use case, and they were using some 62 boxes, and were able to do some X amount of workload. And when we brought in the stream computing, we could do the 3x of the workload with just the 22 boxes. So that's a huge cut down on machines, same type of machines. So, okay, in the interest of time, I'll just take one more question. Okay, this is interesting. With a big data analysis, is it possible to predict the stock market in all type of economic conditions? Well, we can write. All we're saying is this allows you to do analysis, but it all depends on the intelligence that is built into the model. So if the model is not intelligent, if the model is not really the right model, nothing can predict. Right? So I would really wouldn't go with that it will actually predict the stock market. Then there won't be stock market. Then someone else will come. So I think that's a bit far-fetched. The only thing we can see is in the next 2 minutes is it going here and there. How fast can I do it before the data reaches someone else? That's all I think we can talk about. Okay, the last question I'll take is, it says, on one hand, you say the data can be handled in real time. On the other, it's necessary to go to ETL, which requires time. How do you resolve this dichotomy? Interesting. Okay, so I'll go back to the telco example I took. So here, when we're dealing with ETL, loading of this large billions of stuff, right, into ETL and then did the analysis. But when I mean real time, I missed to mention that we are talking about analyzing the data and getting insights before even it is landed on a hard disk. It's all in-memory computing. Right? It comes through network, you do the analysis, and then land it into the disk before it is landed on the disk. So when I'm doing those analysis, I'm not doing ETL. In fact, I'm cutting down on the load part of it by doing a lot of analysis up front and keeping only the relevant data and throwing away non-relevant data, like unclean or duplicate data. Right? But still, ETL is still a larger thing. We cannot just discard that real time will replace ETL. It is not. And okay, getting one by one question. So there is one question, which is big data approach applicable only on relational DB systems, or is it applicable on a newer NoSQL DB system, which are bigger in terms of volumes? No, I'm not talking about relational or non-relational. It's applicable across all. Right? So there has been a talk about NoSQL, which actually people, though they call it NoSQL, they actually meant schema-less. And then we are hearing something called not only SQL, for NoSQL. So it encompasses all of this. So traditionally thinking has been that big data is NoSQL, but that's not the case. Big data is schema-less, schema, structured, unstructured, everything. Okay, I hope I covered most of the questions. There were so many of them I might have missed. If there is something I missed, please you can email me. My email ID will be there, or some way of communication, I'm sure TechGeek will have. I'm more than happy to answer you. Or you can go to bigdatauniversity.com or I will Big Data and comment there. You'll definitely get answers. Okay, I think I'm done with it unless there is anything else. Mohini, you can take over.
Well, thank you so much, Mr. Kulkarni. I'm really thankful to you for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgeek.com by today evening. Thank you all. Have a great day.